In this video, we're going to be looking at how to draw free body diagrams. Here's an example of a question. A force of 7 newtons and a force of 3 newtons act on an object at an angle of 60 degrees to each other. Draw a scale diagram and calculate the size of the resultant force. So firstly, when drawing a scale diagram, you need to decide on a sensible scale and draw one of the force lines. For this scale, I'm going to use 1 centimetre equaling 1 newton. So therefore I'm going to draw my first line. To represent a force of 7 newtons, I draw the line 7 centimetres long. I then need to draw the force of 3 newtons acting at an angle of 60 degrees. To do this, I'm going to line my protractor up, work out where 60 degrees is, and draw a line. This line will be 3 centimetres in length because it's representing a force that's 3 newtons. I then need to complete my parallelogram. So I'll draw my 2 opposing parallel sides, like so. Finally, I can draw my force line. My resultant force will always be from the origin of the 2 forces, where the orange dot is, to the opposing corner. Finally, to calculate the size of the resultant force, I need to measure the length of the line. Let's have a look at this in another example. Here we've got a force of 6 newtons and a force of 4 newtons acting on an object at an angle of 45 degrees to each other. Draw a scale diagram and calculate the size of the resultant force. So again, here's my original point, and I'll draw my first force line. This is representing a force of 6 newtons, and so I'll draw it as 6 centimetres long. I've chosen a nice simple scale, again of 1 centimetre equaling 1 newton. I'll then use my protractor to work out the angle of 45 degrees, and I'll draw my second force. This is representing a force of 4 newtons, and so the line will be 4 centimetres long. I'll then draw my opposing parallel sides and add on my resultant force. I then need to measure the length of the resultant force line, which in this case is 9.3 centimetres. Because of my simple scale, I know that 9.3 centimetres equals a resultant force of 9.3 newtons. 2 tugboats are towing a ship. Each tugboat exerts a force of 8,500 newtons on the ship, and there's a 35-degree angle between their tow ropes. Draw a scale diagram to calculate the size of the resultant force on the ship. So this time I'm going to draw my diagram to a smaller scale. Here 1 centimetre will represent 1,000 newtons. So my first force will be 8.5 centimetres long. I'll then use my protractor to measure an angle of 35 degrees and to draw another line, which again will be 8.5 centimetres long. I'll then construct my parallelogram and add on my resultant force. I now need to measure the length of my resultant force, which is 16.2 centimetres. According to my scale, to convert from centimetres into newtons, I need to multiply by 1,000. So my resultant force will be 16,200 newtons. A lorry needs pulling out by 2 trucks. The first truck exerts a force of 10,000 newtons on the lorry at an angle of 45 degrees to the second truck, which is pulling at 7,500 newtons. Draw a scale diagram and calculate the size of the resultant force. For this one, I'm going to be using the scale of 1 centimetre equals 2,000 newtons. So therefore my first line will be 5 centimetres long. I'll then use a protractor to measure 45 degrees and draw my next line, which is representing 7,500 newtons, and this will be 3.75 centimetres long. I'll then construct my parallelogram and add on my resultant force. Measuring the length of the line, I get 8.1 centimetres. In this scale, to convert from centimetres to newtons, I need to multiply by 2,000. Doing that gives me a resultant force of 16,200 newtons. In our next question, a boat moves through the sea. There is a 3,000 newton force to the west on the boat, and there is a 1,000 newton force to the south on the boat. Determine the magnitude and direction of the resultant force on the boat. So again, I'm going to draw my free body diagram. I will use the scale 1 centimetre represents 500 newtons. So for my force to the west of 3,000 newtons, that will be 6 centimetres, or in this case 6 boxes. I'll then add on my 1,000 Newton force to the south. This will be 2 boxes. or 2 centimetres. Once done, I'll construct my parallelogram and add on my resultant force. I'll then measure the line to determine the magnitude of the force. In this example, it's 6.3 centimetres. So again, I'll look at my scale. To convert from 1 to 6.3, I need to multiply by 6.3. So I'll do the same to the other side. Multiplying 500 newtons by 6.3 gives me the resultant force of 3,150 newtons. In these examples, I also need to give the direction. We tend to give the direction as degrees from north. So using my protractor, I can see that my line is at 252 degrees north. So the final answer is the magnitude of the resultant force is 3,150 newtons, and the direction of the resultant force is 252 degrees from north. In the second question, a boat moves through the sea. There is a 6,000 Newton force to the west on the boat, and there is a 4,000 Newton force to the north on the boat. Determine the magnitude and direction of the resultant force on the boat. For this example, I'm going to use the scale 1 centimetre represents 1,000 newtons. So drawing on my force to the west, it will be 6 centimetres long. The 4,000 Newton force to the north will be represented by 4 centimetres, or 4 squares. I now need to construct my parallelogram and add on my resultant force, like so. Measuring the length of my resultant force gives me 7.2 centimetres. Again, to convert in my scale, I'm multiplying 1 by 7.2, and I need to do the same to the other side. Doing this gives me a force of 7,200 newtons. I also need to work out the direction of the resultant force, so again I use my protractor, and here you can see that it's 304 degrees from the north. Give me a final answer of the magnitude of resultant force 7,200 newtons, and the direction of the resultant force as 304 degrees.